during the first lockdown we did Sierra Hotel 1 Tango Sunday, and most of the sets we did during Sierra Hotel 1 Tango Sunday were great 868 models. And although I've got a shelf full of customer repairs, it's Sunday, and seeing as our trade customers we have a 28-day turnaround with them, there's nothing grass growing around any of them because they only came in last week. So we'll carry on doing some of mine. Now, it was a toss-up between doing a Mustang 2000, which does have some lids somewhere, and for once doesn't have the ballast resistor linked out. This has been given to me by a kind viewer, and I really like the Mustangs. We had a Mustang 1000 a few weeks ago from an end user, and what's that do? Wonder if that's got a Roger bleep on and off switch. There's no reason for me to remove that, you know. That's quite legal. Right, okay, so that's a forthcoming attraction we'll do during the week, because I really like the Mustangs. And some of you don't like the Amstrad, in inverted commas, chassis, a Cybernet chassis, but because the problem there is that most of the Amstrads are either cheap Hong Kong ones or they're fake, even cheaper Hong Kong ones, whereas those Mustangs are always made in Japan. The only thing that lets them down is the squelch. So, what have I got here? Well, I've got, Mark's been already at it, somebody's cut the power lead off it in disgust. It's a Tokai GT868, it's serial number 221, so that's like Tango 221. And this has been lurking on the shelf, and look at the escutcheon. There's a good word, isn't there, for a Sunday? Wow. And you know what? I reckon, I wonder if it's possible that the plastic's still on those knobs. They just feel a bit plastic. Anyway, I'm going to put the front and cases through the dishwasher. We'll remove this escutcheon immediately. Oh! Well, that didn't... I was going to put a craft knife underneath it. And all that. So what I'll do, I'll put that between some timber in the organ workshop in a vise and see if we can straighten that up, and then it'll get glued back down. But I'm not going to do it just by hand. I will do it between two pieces of timber. So it doesn't stop us carrying on with the set. And the other thing we're going to do, which is another video, we're going to do respraying of these cases. Now, as a church organ builder, part of my training had to be, we do have to respray organ display pipes, most of which don't play, they're just there for the amusement to look at, but that's going through the dishwasher. I did just wipe the stuff off with with foam cleanser and a bit of kitchen towel. So we have to spray front pipes. So I did have training to do spraying onto metal with one particular type of paint called Arden Bright, and we use a gold paint usually, which is suspended with aluminium bits suspended in it, and it looks very good. And it's something like £24 for half a litre. It's really expensive. So, the VCO cover's missing. I always look at that resistor there. If it's discoloured, chances are it's changed value, because you can end up with really low power output. Now these can be anything from 1.7 to 3.5 watts. I did once see one which did 4, but it isn't a 4 watt set, it's a 3.5 watt set, whatever they told you in the pamphlet which came with it. So I did have some training in spraying, and any of you out there who are spraying experts for the automotive trade will no doubt laugh at what I'm going to do, but that's what we're going to do. We're going to go over to the organ workshop with this case when it's done in the dishwasher, and it's a bit rubbish. I'm hoping we get rid of this. It's probably half a dead baby mouse or something like that. But well, I'm going to respray this. Now, we don't have to sand all this off, but sometimes you do have to, especially if it's had a hand paint job done to it. So what I will do is we're going to remove the screws entirely. I'm not going to just slip the speaker out, because we don't want those screws to end up getting a respray, or they will look pretty naff. I might choose to change all the screws, especially seeing as it didn't have any screws in the side case. So I'm going to disappear off, and apart from that speaker, which isn't torn, we'll put all these through the dishwasher. When I come to look further, there's no meter in this set. But what I have found on the shelf is a Binatone Binatone Route 66 early version, and there's nothing I'm going to be able to do to put this back together. This is because it's got a broken printed circuit board, it's got the audio IC missing and its heatsink too, it's got the phase lock loop chip, which unusually for a UK set is a PLL02A, which is normally in FCC American sets, and then it has a multiple crystal mixer to make it do UK channels. So that's, and it's got its escutcheon missing, so, and it's had its switches cut off. So this has been bought as a scrap set for a couple of quid, no doubt, from a radio rally, and I'm hoping that meter is going to fit. So I'll just take that out and see. So having got the meter out of the radio, I thought we'll just test the lamp, and the lamp is open circuit, so I'm glad I checked that now and not later. So I'll put a new lamp in that. Okay, well that didn't work out because it doesn't actually fit. So we've got a nice meter with a bulb in it, and that will do for another job at some point. I'll have a look through and see if we've got a scrap Uniden, because I understand the Uniden meters fit in these. I bet somebody's pigeoned it, put it in a Uniden. So we'll carry on without the meter. It doesn't appear to have anything missing apart from the cover to the VCO, and that could mean that there's a snag in there, or it could just mean that somebody was too lazy to put it back when they did the frequency on it. So I'm not going to put a new power lead on it at this stage, because we're never sure whether they can be brought back to any kind of working order. I don't think I've seen a GT868 version of the Tokai before, Tokai. I think we've only seen the GT858, which is the 2-knob version, and that's probably why I bought this, and no doubt I bought it off eBay. They're a bit close, we just have to cross our fingers. I've done my church service this morning, with it being Sunday, via Zoom from my organ workshop, and we'll be in the workshop this afternoon starting the respray job. And we're actually going to spray the lids in the Tango Towers jacuzzi, not actually in the water, but on the cover, because it's a nice 10-foot square space to put some newspapers on. So, right, connect some gear up, extension speaker. We're already starting shorting out the things. And the radio has powered up. It's on channel 20. And it's making some noises. Okay, so we've got the mic plugged in. I had to put a wire onto the public address switch, which was unsoldered or dropped off for whatever reason. We can hear it receiving, and that's 0.4 microvolts for 12 decibel cyanide, so it's receiving very well without any intervention by me. But there's no transmit. Now the current consumption of this without the meter is lower than normal. It's only drawing 150 milliamps. When I press transmit, I'm tripping over a scrap chassis which has migrated to the floor. The floor is also known, certainly in Nottingham area, as the dog shelf, which is alright if you have a dog. It's drawing 260 milliamps when I go into transmit, so it is doing something. So what I'm going to do is I'll get the little monitor receiver on channel 20 the same, and we're using the Midland 42, which we've not field tested yet. I'm just going to put it there and we'll press transmit. Yes, it is actually transmitting, but it's only transmitting out of its early stages, so at least we know the phase lock loop's working and we can go from then on. So I will just look to see if we've actually got power on the dodgy resistor, and then we'll drag the service manual out. This is a floating chassis, if I remember rightly, so we'll connect that to the power supply without, hopefully, shorting anything out. So we've got 13.7 volts there. I've got 13.7 volts there. So what I'm not going to do, I'm not going to unalign it, because the chances are, I'll tell you what we can do. We will go through the early stages of the alignment. We can do that, because I can look at the current consumption on the power supply. So using the Fidelity 1000 manual as ever. So if I remember rightly, they have you go I think it's 207. I think it's 207, 4, 5 and 6. I'll just check that with the layout. Yes, 207, L4, L5 and 6, and then it goes on to the power amplifier. So I'm going to look at the current consumption as I do a bit of twiddling. I'll put the meter to one side because we know. I'll put picture in picture on just in case it suddenly starts up. So I think what's happened here is it stopped transmitting, and somebody's gone in there and probably had a twiddle, which isn't advised because it's quite a swine to set up. And I hope they haven't pinched anything. I don't think so. Anyway, it is transmitting, so we'll start here. So we're at 260 milliamps. No change, no change, no change. It has just struck me. There's a possibility it may not transmit because of that. I'll just link that out with a crocodile clip lead, just as a precaution. So we're not having any change. I'll bring back the monitor receiver and we'll tune for best quietening. I'll put the monitor receiver nearer the microphones. I'll use the ceramic tool. We're going for least FM hiss. Now that's interesting, we're getting no difference there, which means we'll get probably no difference there either. So I think it's time to get the Russian RF probe out. I'm going to switch it off because it's going to be a bit of a faff with the way the power lead is as I turn it over. I don't want to short anything out. Switch it back on. So we're still doing 260 milliamps. So we'll look at the transistor there. So we're getting absolutely nothing on the PA transistors. That's the driver and that's the output. I don't need to take that screen off because the fault isn't likely to be there. So it's going to be in the early stages. And we had quite a difference into the monitor receiver between L6 and L7. So the chances are that transistor 17 is either not working or transistor 17 isn't getting any power. So let's see what we've got on the base and what we've got on the collector. Especially if I can match the patterns up. Have they got a... Yes, they have. Doesn't help that much. It just tells you the parts they've bodged on the back. At least it tells you how the meter's wired, if we had a meter. So we know that's the PA. I can see the footprint of L7. So that is the emitter. That is the collector. And that's the base. So right, let's key up. Okay. So as you can see, we've got the signal on the base quite clearly. So we'll go to the collector and we've got nothing. Okay. I'll put my Russian meter to one side and we'll get the voltmeter out. We're looking at transistor 17, Q17. So we're looking at here on the circuit diagram. So it's getting its power through L7. Just tell you, make sure I'm not telling you a load of bull. So the regulated power is to that rail there. And because we're getting power further down, these resistors must be intact. So, unless they change value slightly. So let's have a look. Coil 7, so on the collector we should be having some kind of rail voltage. So the collector is the center one, which is that one. We actually have no power coming to the transistor. So if we assume you know what, I'm going through all this and the stupid negative leads off. So we'll just start again. The collector. So still have no power on the collector. So we'll go up to the coil. Well, it could be one of those resistors then. Not quite sure why the lower stages operate unless the VCO gets its power, which it probably does when you look at it. The phase lock loop section gets its power, no doubt, from somewhere else. So let's go for resistor 63, which is 10 ohms. So we'll find resistor 63. Oh, 63 is our favourite, the one that fails, and so we had power there, didn't we? No, it's definitely Mr. Tango. Yep. So on the circuit, resistor 63 is there. So why isn't it getting to L14? We'll see whether we can find 63 on the back of the board. So I've got to. I could actually, I could photocopy this, then reverse it, so that we've got a layout. But at the moment we're not struggling. So we know that we've got. I'll just move the camera slightly across. Oops, not that far. Probably about there's the best compromise. So we know that resistor 63 is there. So I've just got to identify where we are. our driver transistor. Just follow this down. So we've got the 13.7 volt rail voltage there. How strange. Hang on a minute, there's a chopped wire there. Is that for the meter lamp, or is that something important? So I'll just follow that back. We'll pause the video. Okay, so after that complicated diagnostics, it was nothing complicated at all, because this radio, instead of being the resistor, is it 82, this goes to the PA switch, it turns out, and the PA switch was dirty. So I've cleaned the PA switch, and we now are starting to have transmit. So I'll put that back and we'll carry on. Okay, so I started the other video where we've taken the cases out of the dishwasher and we've started to do a respray job on those. So I've just done the primer and that is currently drying. So we'll come back to this video and hopefully we'll see whether we can start a tune-up. There we are, 1.6 watts. What more can you ask for? Wow. $3.6. $3.9. Okay. What we're not going to do is touch that one because that is the 54 meg trap. So I'll put the spectrum analyzer on ready to do that. I was going to say we'll do the RF meter, but there's no meter, is there? So we'll do the deviation. Wallow. 1, 2. It's actually spot on. Wallow. Probably just bring it up a fraction. Wallow. That's it. I'll do nicely. So that's the deviation. So that's not being messed with. In fact, it's not a messed with set, it's a set that's gone wrong, and then it's been scrapped. And it was actually the PA switch. So let's check if it's on frequency. Oh, just for the record, we'll look at low power. And it's 270 milliwatts. It's not adjustable on this chassis, and that's supposed to be 400 milliwatts, but that's how it is. So, frequency. Just go over camera 2. Should be 27,79125. I've got the feeling it was a little bit off frequency. The fact it's high tells me it's been fiddled with, which of course we know it has because the cover's off. But it looks like they've only messed with this. (27,79126) toggling 7 is ideal for me. Always leave them slightly high because they drop with age. I'll find a cover off a scrap set. I'm sure we're going to have one somewhere kicking around. Can't see one to hand right at this moment. I've got a little bin of tins up here. Yeah, found one. Oh no, that's not for this type of set. That is. So I'll put that cover on right away. So I've put that in. You've got some bendable lugs here, and it's good practice to solder it between one and the other because these may not make a good electrical contact, and if you don't, you can end up with microphony. Microphony is where you tap the radio and it when you're in, well, transmit and receive, and you end up with that being amplified. Clickety click click click. You don't even need a microphone. Some radios are inherently like that. The Tate 500 business radios were like that. In fact, we've got one of those to put on ham radio during the course of this week. Might do the video on that. Right, so we'll just key it up now, having done that. From cold, 3.6 watts. And that's jolly good for one of these. So now we'll move over to receive. And it's already very good, as we said. Yeah, I mean, this isn't like it's a messed with set, it's just gone wrong. But we'll go through it. Spot on. Now we go over to the ones which are IF, so we need a different type of signal. Slight improvement there. I've shown before the method shown in the service manual, and I'm not showing you what I'm doing. The method shown in the service manual uses a sweep generator, which I've shown you on the other bench. I'm on test bench 3, test bench 2 behind me is where the sweep generator is. It's a very long drawn out method and it doesn't give any better result. And I've got a feeling that when these were made in 1981 that they probably weren't into cyanide meters in Taiwan and used a different method, you know. But we've got these instruments, so we're using them. You don't have to, I mean, this one we can take readings off, but not all cyanide meters you can take readings off with that, not directly. You have to do a bit of maths. But you know, when you're setting a radio for the best possible results, you don't necessarily have to have a constant reading like I do on this one. There are cheaper meters available. And I've said before, there's that Marconi one, which isn't a cheap one, but it's one of these which isn't calibrated in such a way that you can do direct readings, but it still gives you the right tune-up result. So we're going to go over to the two difficult ones. I'm going to put an even bigger signal on. Normally we'd look at the discriminator, but it doesn't work like that. It's ratio detector on this radio. So we'll start by kind of doing that and then dropping the signal to there and doing the other one. I think we're there. Let's see what we've got now. I think it was 0.6, wasn't it, for 12 dB cyanide. It was now 0.25. Yep, I'll go on the other scale. On the other scale, it says 0.28. There's a bit of discrepancy between the two scales. So on the lower scale, 0.28. So we'll go for that. Oh, gone and knocked our frequency. So for 10 decibels, got 0.25 of a microvolt, and if the radio will do 20, and it will, it's doing 1.6 microvolts. So that has improved it. It surprised me, but it's improved it. I don't think it's been messed with, but one of these IF ones was very slightly out. It might have been touched. So I can't do the signal meter with you, but we can do the squelch. So I'm going to turn the squelch to full, and we'll now, I'll put this on the attenuator controls. We'll now switch the signal generator back on and advance the signal generator. That's 10 microvolts. I don't want it to come in at 10 microvolts, that's too wishy-washy. So we need to do this. I can never remember which one it is. It's going to be one, isn't it? Yes, because we've got the squelch control there. And that goes through that preset there. And then you have an AM detector takeoff. It's a weird way of doing it. Ah, that's too tight. That's spot on. So 100 microvolts is S9, and that's with it at full. So now we'll turn the squelch to minimum. These sets have much less FM hiss than normal FM sets. They don't have a clever discriminator chip, as I say. It uses some ratio detector method. There's the squelch, and we'll switch the signal generator back on. It's parked at 0.3 of a microvolt. So it's coming in at 0.6 of a microvolt and it's leaving us at 0.5, 0.6, 0.5. So it's got some hysteresis. That's where we want it. So I see no reason why we need to change any other parts, and all I'm going to now do is start putting the radio back together. So it'll get put back together, there'll be no meter. Oh, we've got a lot of boxes of stuff in storage at the moment. We're having building work in June and July. Believe it or not, they're building a private chapel, which will have a permanent pipe organ in it. And at the moment, because of that, we've got 60-something boxes of stuff in storage, and things like odd meters and scrap sets are amongst all that. So I'll be back with some bits. Another thing we were going to do is looking at the spectrum analyzer, and we will do that right now. So if I put in the fundamental frequency, if I did that, I didn't. So there we have our 27 megs. So let's go and look for the naughty one up the road. And there's our naughty one at 54. So let's see if we can reduce that with the trap, which is there. Tell you what, it might be easy to put the marker on that. So it's a little higher at -46. So that's adjusted it to about -54, something like that. So we're in spec now. And we'll just check back that we've still got 3.5 watts. It's been now keyed up for a couple of minutes. And it's 3.7 watts. So we're doing great. I'll get Mr. Chippy to change the power lead on this. Meanwhile, we're carrying on with the lids. So it's on there early, it's on channel 19, and when I came to put the knobs back on out of the dishwasher, I discovered they've still got the plastic on the inserts. And so they've never had any scratching because the manufacturer's plastic has saved that. Didn't say I could get the plastic off. So that can go there. Drops it in the bin. Luckily it's landed on something on the top. Put it on in the correct position would also help. There we are. So yeah, we've seen better, but I've more or less got that front straightish. new screws all round, including the speaker mounting screws and a new power lead. So it's probably worth a fiver now. One and a Roger. Nineteen a Roger. Okay, so we'll do an on-the-air test for that later. So that's another one resurrected from the scrap bin, but we need a meter. So if any of you have got a scrap Fidelity 1000 or a scrap Uniden audio line, realistic, which has that kind of meter on it, or one of these other GT858s, I'll be happy to buy that off you. Every time I buy scrap chassis, you know, oh, that's not one I, you know, it's like that one. I took the spit. I've taken it off that. I haven't taken. It was the what's this one? The meter's missing. Meter's missing. They're all the, you know, this is how I end up getting them. Meter's missing. Everything's missing. So the time, you know, I just don't get them with meters, so that's our problem. So thank you for watching. Hope you found that interesting, that in actual fact that radio had been discarded because it was the PA switch which was in fact faulty. Thank you.